neural network, and from then we just change the values between the two function blocks. Sometimes we present 0 to these function blocks, and we can derive some of other neural networks, by making many configurations if we want. So we just change these values sent to a block to another. So on the fly we can change this configuration, we can change the values of this neural network and its architecture. We developed three kinds of agents: the observation agents, the diagnostic agents, and the execution agents. The OA, observation agents. These agents aim to discovering anomalies in value measurements in the sensor or accuracy in the actors. So it's just monitoring the network. The diagnostic agents consult the knowledge base to determine the type of problem occurring in the field bus detected by observation agents. And finally, the execution agents. As soon as the problem is detected by the observation agents and diagnosed by the DA, the execution agents change the function block logical links to allocate an algorithm, in our case an ANN, that can repair the problem. Let's show an example made in our laboratories. This is our laboratory test environment. The plant lab is composed of two cascading tanks. The water flows out from the small hole of tank 1, falls into tank 2. This tank has a small hole through which the water falls directly in the reservoir, and a pump impels the water from the reservoir to tank 1. An FF loop of current from 4 to 20 milliamperes converter is used to send signal to the water pump. A foundation field bus network is connected to a supervisor computer through the Ethernet network interface. All device configuration processes are carried out from this computer and later supervised. Signals are sent to the pump, input to a load for water injector or not in tank 1, and control the water level in both tanks. There is also a PC, an OPC client, that sends a simulated noise signal by the dotted red line to a device. This environment is used in your example, to detect and remove a noise. First, the agents undergo a learning process. It is made outside the process. It's made offline. The observation agent will be trained to predict a sensor output at a given moment based on his past output, considering that the signal is noise-free. The EA will be trained to act as a noise filter. The knowledge acquired by the agent is stored and can be used by another agent. When the learning phase is over, the observation agent starts to monitor the device, which will be allocated to the function blocks. This agent is allocated as a prediction ANN in the field device. It monitors the output signal and predicts its corresponding value in the next step. In our test, a PC, an OPC client, sends a simulated noise signal to the device monitored by the agents. In a half of samples, the sensor output signal starts to exhibit different behavior from the predicted. In this moment, the noise is added in the signal. Note that the signal and predicted signal and measured signal is the same, or the agents can predict exactly the next signal on the field device. So in a half of samples, noise added by the opposite client is put in the signal. The difference between the compared signal is considered a problem by the way. The way it will send a message to an execution agent, we try to correct it. So here, when a noise is added, we can see a difference between the predicted and measured signal. Here we can see this difference before and after the noise added. At this moment, the function block parameters change to allocate the EA as an NN acting as a noise filter, previously trained in the learning phase. This function block allocation, the EA, the execution agent, continues until the problem is solved, permanent solved. After which the function block parameter change again to allocate the observation agents and restart the device track. Unlike some conclusion of this work, unlike other works in this area, we show an SMA architecture will be enabled the implementation of control configuration at field device level. We aggregate in our work machine learning through artificial neural network and FIPA agents component. The shown implementation brings a basic agent feature, the adaptation. Function blocks allocation will change to adapt to a kind of problem without the user intervention. So, we have important issues that can be taught here and were critical to develop in the future our work. We have a real-time function block configuration change. I will try to explain. The field bus works in a microcycle. So it executes every task in the determined microcycle. At the finish, you start the new microcycle again, doing the same or other activities in this microcycle. When we can change this interconnection, change the value passed by one function block to another, it doesn't possible in our tests change every interconnection at the same function, at the same microcycle. In sometimes we can, but in other cases when the network is very, there are many tasks, we don't condition to change every interconnection the same microcycle. That is a problem. That is a moment we don't have any neural network. We have the structure, another structure there. This is a problem we have to study. We don't study yet in the case of online command change. We change the sensor or we change the actuator to another how this network will behave. So we studying a reasonable duration of learning phases. This is a typical problem in the neural network. So we have to understand how is better time to the agent learn and will then stop and then start acting. Which is the best time with the best error that we can consider. Flexibility limitation in case of other situation like a sensitive inducer or big size facilities. And we will have to study the knowledge base. I told about a knowledge base, but it doesn't have a knowledge base. We have a great repository to store the weights of neural network that can be used in another agents. We have to study how can we use some kind of knowledge, some kind of knowledge like ontology, like frames or other kind of knowledge-based story. We would like to acknowledge the CE